this is Britt Caswell with another example video. In this video, I'm covering example 3 in section 2-3 in the SavvasRealize Algebra 1 textbook. In this video, we are using standard form to talk about horizontal and vertical lines. So this example starts out by having us consider standard form when a equals 0. So if I cross out that a right there and turn it into a 0, well, do you see that that term falls away, and it leaves me with by equals c? Now I can go ahead and solve for y here, right? I can divide by whatever number b is. It doesn't really matter as long as it's not 0. And I get that y is c over b. Now remember, in this situation, c and b are just numbers, alright? They're like 4 and 13 or something like that, alright? So what's happening is we are getting y equals some kind of number. Okay, it could be a fraction, it could be a whole number, it could be a square root if we really wanted to get wild. But it's just y equals a number. So what I think about this is that the x value doesn't really matter. Okay, it doesn't matter if x is -5 or 0 or 300 billion. It doesn't matter what x is. Whatever x is, because it's getting multiplied by 0, you end up with just y equals whatever number. So say, for example, I have like y equals 3. Again, it doesn't matter what x is. Every x value has the output of y equals 3. So when x is 0, y is 3. When x is 3, y is 3. When x is 7, y is 3. When x is 10, y is 3. When x is -10, y is 3. What do you see here, guys? Do you see that it's a horizontal line? That's what y equals 3 looks like. And people get mixed up with horizontal and vertical lines because it's parallel to the x-axis. Okay, let's try another one. Let's do y equals 5. Well, when x is 0, y is 5. When x is 3, y is 5. Okay, it doesn't matter what your x value is, y equals 5. And that's what the graph turns into, another horizontal line. It can work with negative numbers too. Okay, if you have y equals -7, 4, 5, 6, 7. When x is 0, y is -7. When x is 3, y is -7. When x is -10, y is -7. And it all just makes that horizontal line. Oh, it's a terrible drawing. Sorry, guys. Now, what about if instead of a being 0, b is 0? So, we replace that with a 0. Well, that term goes away, doesn't it? And you get ax equals c. And a and c, those are just numbers, right? So I could divide by a to get x alone. And so in this case, I have x equals c over a. So x equals some kind of number. And just like the example up above, it doesn't matter what y is. So if I have like x equals 2, you know, when y is 0, x is 2. When y is 4, x is 2. When y is -10, x is 2. And so that x value remains a constant. And it turns into a vertical line. A terribly drawn one, but a vertical line. And I could try it with other stuff too. If I have x equals -5. When y is 0, x is -5. When y is 10, x is -5. When y is -10, x is -5. It doesn't matter. You can pick whatever y values you want. Y is 6 million, x is -5. And there you have it. You have vertical lines from it. So let's take a look at some of the equations they might give you. So they might give you something like 3y equals negative 18 here. We're not going to freak out, right? We're just going to isolate the y. So this is saying 3 times y. So I'm going to divide by 3 to get rid of it. And I get that y equals negative 6. So in this situation, it doesn't matter where I am on the x-axis. My y is negative 6. 3, 4, 5, 6. Okay, negative 6 is here. So it doesn't matter if x is 1 or 2 or 3. That y is negative 6. So this is a horizontal line right here. Alright, and one more example. Here we are, we have 4x equals 12. So again, we want to isolate the variable. Right now we have multiplication, so I'm going to divide by 4 and get that x equals 3. Because there's no y value in this equation, it doesn't matter what y is. Y can be any value, and x will always be 3. So this is a vertical line instead. Alrighty, so there's vertical lines and horizontal lines using standard form. Until next time.